So we're up to matrices. So question 27, so 42% of our it's mainly my classes, so got that correct. So the following transition matrix, T, models the movement of a species of birds around different locations from M to N and O the next day. So it says in the long term what's going to happen. So where you want to see. So this is obviously a transition. When you do the long term, or essentially the steady state, so we could say the steady state is the long term, that's the same thing. What you want to do is you do your transition to a high power times SO, yeah? Or you can actually times it by any state that you want. Now, because they're just talking about the birds and where they end up, what I'm going to do is I'm just going to do the transition. So I'll type this into my calculator, raise it to a high power, and I'm just going to times it by, so I've got M, N, O, and I'm just going to chuck, it doesn't matter where I chuck it, I'm going to say like 100% of the data is in there, okay? So when you do that, you'll see where it'll produce, and it ends up producing this. So you have 0. It has a very, very small number, which means 0. If you see e to the power of negative something, it means it's 0, okay? And then you'll see this one is close, says 100 or whatever, and 0. So what you know is all the birds end up at n, yeah? That's what happens in the long run. Now, it doesn't matter how you do that transition. If I times it, say I want to break it up even, and I said 33, and I don't know, just 34, you will still get that same answer. Do you understand that? That's what the long term means. It doesn't matter how they began, you eventually get to this spot, okay? So you can always put a percentage. If you put 100, then you can see where they all land. You know, if they say half of them land there, you know, 50% is half. So in the log, if you look at it, no birds will. Which of the following statements best represents what will occur in the long term? So no birds remain at location M. Is that true? Yeah, that seems pretty good. I'm pretty happy with that, but that looks good. Let's double check. No birds will remain at location N. That's wrong. They're all there. All birds will end up at M. No, M. M for Mary. All birds will end up at location O. No. And equal number of birds at all locations. No. Okay. So how many of these statements are true? So these type of worded questions are ones you can do in reading time, because that's all you can do is really read and think about it, all right? So they are the worded ones. Try to do them. So all square matrices have an inverse. That is not true, because remember, if an inverse can only occur, so this is where it's good to write, can only occur if the determinant, if the determinant doesn't equal 0. So remember, if it has a 0, then it doesn't have an inverse. So that is not true. So the inverse of a matrix could be the same as the transpose of a matrix. Well, that is true, because if you have an identity matrix, so say, so we're going to say this is true. So if you think about it, if you have the identity matrix, which is 1, 0, 0, 1, so remember it's like a 1. So if you do the inverse is going to be the same. So the inverse would still be the same. Now, if I transpose this matrix, that means that goes that way. So you've got 1, 0, and then the other one goes 0, 1. Did that produce the same? Yeah. So that's why I'm saying. So the identity, if you do the inverse of the identity, you're going to get the exact same thing, all right? So it's sort of knowing a few of these facts which is going to make you a bit better, yeah? The determinant of a matrix is equal to 0, then the inverse does not exist. Well, I just wrote that fact, so that is true. And is it possible to take the inverse of an identity matrix? So I just did that. Yes. So that is true. So how many of these are true? Is D. Okay, so just really knowing your stuff through that. So they're important to do in your revision so that you have all your facts right in your head to help you. So question 31, a species of bird has a lifespan of 3 years. So these are the Leslie matrices, okay? So the females in the species do not reproduce in their first year, but reproduce an average of 4 offsprings in their second year and and 3 in their year. So they're just pretty much saying that this is year 1, year 2. So you could see year 3, okay? And here's the Leslie. Remember, Leslie matrices only talk about females. That's why they're chucking that word in there. It doesn't really mean a lot for you in the working out. It's just like how they work out this data. So the element in the second row and the first column, so second row and first column, that on average 20% of the population. Now, if you remember, these things were the survival rate. So it's saying that 20% of the population will survive to their second year. Okay? I'm tipping that this was not done well, mainly because... Did I have this one circled? No. Oh, because I was about to say this is pretty easy. Okay, one particular week in the school year, students in Phyllis Primary School can spend their lunch break on the playground, basketball courts, or oval or library. Students stay at the same location for the entire lunch break, and then the transition from one day, so day to day, is how they change. Okay, the transition diagram is incomplete. So on Monday, 150 students spent their lunch at the playground, 50 students at the basketball, 220 at the oval, and 40 at the library. Of the students expected at their lunchtime on Wednesday, the percentage of students who will spend their lunch on the oval were who had spent their lunch on Tuesday. So really what we have to do is we have to go through, this is the last question, so you're going to have to do a few things. So the first thing is you need to set up the transition. So you've got to use, it said though, the transition diagram is incomplete, so you may have to add some things in there. So what I'm going to do is this is the way, it won't matter how you set it up, as long as if you're going to go this order, your state matrix has to go this order. All right, so I'm looking, it's sometimes easy to do the ones that go to themselves, but as you look, they're the ones that they've missed out, yeah? They haven't got the percentages. So now I'm just going to cross through. So I might you might just highlight through. So P to O, so from P to O was 0.4, and just keep going, highlighting through. So I'm not going to, so if you go through all of them, now all of the ones back to themselves are not there. So if you look, so I'm missing out on the diagonal ones. I think all the rest are there. Okay, so these ones I'm going to do in red, these ones were missing. Now, they have to, what do the columns have to add up to? 1. So by doing that, see this is 0.7, adds up to 0.8, so that one must be 0.2. This one adds up to 0.7, so it must be 0.3. This one is 0.3, and this one 0.3. So there's the first mark, because they're generally 3 things you got to do. So that's the first thing that they wanted you to know. Now, you got given Monday. So Monday, I'm going to set up Monday. And I have to do it in the same order as I said there. So they said 150 on the playground. They said 50 students on the basketball. So I should have put 50 down here. 220 on, what was it? 220 on the oval and 40 in the library. So that order has to match my transition. So this is like state 1. Now, I need to know what, you can give it S to O if you want. Now, Tuesday would be the next one, so S1. So you can just do the transition times the one before, and we get Tuesday, and I'm just going to write them out. 132, 54, 134, and 140. So you're all aware how I did that? So, yes, I did T times SO, if you like, or Mondays. And then we've got, so that is Tuesday, and then we also needed Wednesday, S2. So if I do Wednesday, I've got 144, 57, 133, and 127. So I've got all the days they're talking about. Now, when they're asking a percentage, this is important. So we're getting asked a percentage. A percentage is always an amount out of a total times 100. When they talk about the total, you'll often hear they'll say of these things. So if you look at of the students expected to have their lunch on the oval Wednesday. So if you look oval Wednesday, yes? So of the 127, the percentage of these students who had spent their break on the oval on Tuesday. So we want, if we look at this, so this amount, we want the ones that were on the oval on Tuesday that moved on to oval. So of the 140, how many go to oval back to oval? What was it? Yeah, 30% go to oval. So we want 0.3 of the Tuesday ovals. So if you do that, that's essentially, you just go 0.3 times 140 over the 127 and you times by 100. So if we did that on our calc page, so just 0.3 times 140 over 127 and times 100 if you like, and we get 33.0, so we get 33%, so C. Okay? That was the last one. All right, so that one,